welcome back to Miss Chemistry, and we're going to continue learning more about carboxylic acids. So here, as you can see, there's glycerol. So what is the IUPAC name for glycerol? You're right, it's propane 1,2,3 triol, and it's obviously triol because there's 3 hydroxy groups, and it's propane because there's 3 carbons. So you guys remember esterification, when we reacted a carboxylic acid with an alcohol to create an ester in water. That is esterification, if you guys watched the last video. Well, what if we reacted the glycerol with 3 carboxylic acid groups? Now, this is esterification. So what happens is water gets eliminated because obviously the end product is ester and water. So ester is eliminated, producing 3 waters and an ester, which is a triester, which is known to be a triglyceride, which is known to be a fat or oil, whatever. So fats and oils used in many products that we use to clean ourselves, to wash ourselves, or other things. I don't want to say. I know too much. But so fats, yes. So fats are solid at room temperature due to mainly being saturated. So due to more carbon single bonds, those are fats. So the more saturated the compound is, the less hydrolysis you would have, right? Remember that. That's like an answer in an exam, okay? And then oils are liquid at room temperature as it mainly contains unsaturated fatty acids. So C double bond C, carbon double bonds, you know. So that's why. Okay. Next, talking about hydrolysis. Esters can be broken down by, aka esters can be hydrolyzed by 2 ways. So first is acid hydrolysis. Now, its reagent is dilute hydrochloric acid, and the conditions are heat under reflux. Yeah, in the exam they mainly use hydrochloric acid, but you don't actually react it with hydrochloric acid. It's in the presence of hydrochloric acid because the hydrogen ion acts as a catalyst in an equilibrium reaction, which is what I'm going to show right now. So this ester, for example, ethyl propanoate, reacts with water in an equilibrium reaction, irreversible reaction as well, to create a carboxylic acid and an alcohol. Because remember, esterification is from carboxylic acid and alcohol to making an ester in water. This is just the reverse of it. That's why it's a irreversible reaction in the presence of the hydrogen ion, the catalyst. Okay, number 2, alkaline hydrolysis, aka base hydrolysis, aka saponification. Saponification used to make soap, so with sodium compound, you know. Base hydrolysis accepts hydrogen ions. Alkaline hydrolysis, alkali, sodium hydroxide. I'm going to show you right now. So the reagent is dilute sodium hydroxide. Conditions is heat under reflux. And here I did a structural formula of an ester reacting with sodium hydroxide, the alkali, and then it creates sodium propanoate. Why can't I say that word? I'm like sodium propanoate. Sodium. Okay, forget it. Yes, that. Yeah. I just wrote the structure formula above that, just in case you wanted to see. And then we have, it creates methanol as well. This is because from the ester, you can see from the ester, and you can see the CH3 at the end of the oxygen in the ester. You can see here in the structure formula that the CH3 is broken off. So therefore this actually, what the hell? Oh wait, never mind. Oh my gosh, I thought like I did something wrong. Okay, never mind. No, so yes. So yes, the OH from the sodium hydroxide attaches to the CH3, which creates methanol, and then this sodium, which is positive, is attracted to the oxygen of the ester. So then it creates the ionic bond, as you can see here. Sodium hydroxide conditions must be warm sodium hydroxide. And as you can see, this arrow is a single arrow. It is not 2 arrows. It is not 3 arrows. It is not 5 arrows. It is 1 arrow, okay? 1 arrow, guys. 1. Which means it went to full completion, which means high yield, which means more money for us. Okay? So that's very good. Okay? Very simple. And then we have this. So what I shaded in red right now, this is the carboxylic ion, which is an anion of a carboxylic acid. So we know anions, they are negatively charged in it. So that was really cringe, sorry. The negatively charged ion of a carboxylic acid. So therefore it is, I think I wrote it wrong on this PowerPoint, but I'm just going to say it. So this basically means that this anion is resistant to be attacked by weak nucleophiles, such as alcohols. Remember when I said before, alcohols only have one OH group, meaning that it can form one hydrogen bond, therefore it's weak. So therefore it's also a weak nucleophile. And therefore, since this carboxylic ion, which is an anion, is resistant to be attacked by these weak nucleophiles, so therefore the reaction is not reversible, therefore cannot react. It's like this carboxylic ion is like rejecting it, you know, like it's like, I don't want you, get away from my life, get out of it, like, you know, just don't, it's just not clocking, you know. Okay, so here I wrote an example of an ester reaction with sodium hydroxide, but this ester is very special because usually it's shown in exams, but of different things. I just did, you know, the zigzags just to show like, oh, there's a different compound there. But so this is going to represent a fat or an oil or whatever reacting with sodium hydroxide, which would create an alcohol and a sodium compound here, which is shown here. This would usually be shown in the exams. So the sodium compound is used for soap. That's a 1 mark answer, guys. Soap, sodium soap, okay? And it creates glycerol, which is the alcohol here, the triol. And this glycerol can form hydrogen bonds with water. And the uses for glycerol is that it can create toothpaste, lotion, and cream. Things we use to clean ourselves, things we use to moisturize, you know, things we use to keep us amazing and glowing and healthy, right? Yeah, so since glycerol can form these hydrogen bonds with water, it can be used in all of these. And that is all. That was quite short actually, guys, I'm not gonna lie. But I hope this helped with your revision. Do lots of exam questions. Exam questions is key. Do your exam questions. They repeat all the time, okay? So, yeah. Okay, guys, for some reason, it just keeps on cutting me off. And I'm getting really annoyed about it. But, yeah, so, bye, guys. Good luck in your exams. Bye-bye.